Well, welcome everyone for another episode of Coffee Sessions. I am one of the hosts, David Aponte, and I'm here with my co-host, Demetrios Brinkman. Demetrios, say what's up.
What's happening, everybody? I'm talking nice and soft because it is late at night where I'm at right now, but I could not miss this chance to talk with our two wonderful guests.
Yes, we have two very special guests with us from Coiled, and I'm gonna let them introduce themselves, tell them a little bit about who they are. So we have with us Hugo Bowne-Anderson, and we have Matthew Rocklin. Matthew Rocklin, can we start with you? Tell us a little bit about yourself.
Yeah, sure. Thanks for having me. Thanks for having us. My name is Matt. I've been a software engineer in the open source Python space for a long time. So libraries like NumPy, Pandas, Scikit-learn, Jupyter in that space. I mostly think about scalable and parallel computing. So how do we scale out that existing ecosystem of projects? And I do most of that work in a project called Dask, where I've been one of the lead maintainers for the last 5 or 6 years, ever since it got started. And then more recently, Hugo and I and a few other folks started a company Coiled, which provides hosted solutions around Dask. That's, I guess, what we're talking about today.
Excellent. And Hugo, how about yourself? Tell us a little bit about yourself.
I will, and I'd just love to thank you both and the entire community for having us here today. And I love that Demetrios is slightly whispering. There's a certain hypnosis to his tones that I enjoy a lot.
It'll complement your booming voice, Hugo.
Exactly. What a dynamic duo. So as Matt said, we founded Coiled earlier this year, where we're building scalable products for data scientists and people doing machine learning. Essentially, hosted deployments and these type of things to make it easier to get all of your data science up and running in clusters on the cloud and on-prem and all of these types of things. One of the many reasons I'm attracted to the work we're doing is because I'm really interested in lowering the barrier to entry to data science and analytics and machine learning. My previous incarnation, I was doing this in the education space at a startup called DataCamp. Prior to that, I worked in academic research in cell biology and math and biophysics. And I saw I think, a state of data tooling for basic research, which required a lot of work to lower the barriers to entry. I think all the products and the tools are being developed very well, but it was very difficult to access them. And we've seen a lot of work happen in there in the past 5 years since I came to the dark side, as I say, of industry, away from basic research. So that's pretty much an intro to me. I do find it interesting that we're speaking with the MLOps community today, because one of the things we're working on is taking a lot of the DevOps out of data science. And what I mean by that essentially is to be a practical data scientist these days. There are so many moving parts you need to do, from all the software engineering stuff to the DevOps. And if you want to do that as a working data scientist, more power to you. But I think a lot of data scientists want to get their analyses up and running and don't necessarily want to get too involved with all the Kubernetes and Docker containerization and these types of things. So that's kind of a brief idea of what we're thinking about. And I'm excited to chat about that more with you all.
Yeah, that's awesome. You guys have quite the backgrounds. I'm so curious just to hear how that led you to your passions, I guess, dealing with distributed computing and making things easier for data scientists to do work. Where did that inspiration come from? I would love to hear from each of you, just some of the history, the background of how you got to where you are.
I would love to answer that by deferring to Matt.
Yeah, that's a great question. There's a history here in like the Python lore, right? So walk back 5 years ago, Python was used everywhere for data science, machine learning. So NumPy, Pandas, Scikit-learn, TensorFlow, PyTorch were on the scene. Maybe Theano was there early on, and everything was great on a single machine, but just did not scale to multiple machines, or even to multiple cores or out-of-memory data sets. I was working at Anaconda at the time, and Anaconda is like a for-profit Python company. Anaconda said this is a structural challenge to the ecosystem. Let's fix that. In the same way they kind of fix packaging with Conda, at least packaging if you care about libraries that aren't just Python.
Got you.
So we built Dask, and Dask was actually originally designed to be like a parallel NumPy. We thought, look, let's just parallelize NumPy. The whole other stack will come on top of that. That wasn't the case. We had to do lots of social work, lots of cultural work, and we ended up sort of massively contorting Dask to be this thing that could be snuck into all these other libraries. So my origin story is actually much more about talking to other software engineers who wanted to support other user communities. But after seeing that leverage, it was actually really exciting and really satisfying to affect whole domains of science and whole domains of industry through all of these other software libraries. So we help NumPy parallelize itself, and now suddenly lots of cancer researchers or genomicists or climate scientists are solving their problems at scale. And that kind of impact has just like really fueled, I think, a lot of us in the sort of Dask and PyData development communities.
That's awesome. It sounds like both Hugo as well, you mentioned that you studied, I guess, in the sciences as well. So you have, scientific computing was essentially what you guys were working on, right? So, processing a lot of biological data, and maybe some of that, it requires, some of those, we're going to get into some of the challenges of why it's hard to do distributed computing. And in particular, why Python can sometimes be just such a pain in the ass with with parallelizing things. But yeah, you're right. Maybe it's becoming even easier now.
I would claim it's always been the easiest language, but that's again further on in the conversation maybe.
Yeah, I would love to hear more about that. But yeah, sorry, Hugo, how about yourself? Tell us a little bit about how you got interested in the space. And I know you've been in the education scene for a while now. Actually, that's how I heard about you. When I was in grad school, I was utilizing DataCamp to really get me some hands-on experience with things. And I just some really great projects. Go ahead, Demetrius.
I gotta say that, Hugo, before we got on to this podcast, David, every time we would say, yeah, we're going to be with Hugo, David would give his best Aussie accent. You would go,
oh, we got to hear it then.
Hugo Bowne. It's Hugo Bowne-Anderson. I can't do it as well as you.
No, that's good.
Yours is so rich, man. I love your voice.
And it's me. I mean, there's the old joke, right? That Charlie Chaplin later in life entered a Charlie Chaplin lookalike contest and came third. Right. So there will be a day when I am no longer the best me impersonator. But you mentioned something really, really important about, I think, access to tools and skills. And my background you're right, I did work in basic research. I also worked with a lot of biologists. I worked in a research institute with hundreds of research biologists who were generating a lot of data, and they didn't have the tools or the skills to actually analyze them. And at that point, I realized that, in addition to basic research, I could play at least a small role in enabling researchers to have access to the skills and tooling that will allow them to do their work and feel nourished in doing their work. And one side of this is education, as has become really apparent, particularly with the large amounts of data being generated now after the hype of big data has died down, and the size of models that we need to build in some places these days. And to be clear, small data and small models is like, I always encourage people to figure out how to optimize their pandas code before going and using Dask, right? And do you need, plot your learning curves? Do you need all this data? Because the answer may be no. But if you do, there has been a serious lack of enterprise tooling to do so. I think a lot of the OSS stuff plays an incredible role for individual contributors, but for organizations at large who are adopting open source software at scale now, we need a really fat long tail of companies to support these endeavors. And that's one of the several origin stories of Coiled as well. Matt half jokes that he didn't necessarily want to start a company, but there were so many requests and such a need that it made sense for us to do this at this point in time.
I think, so working in a drug discovery company at the moment, I deal with scientists all the time. And it's an interesting dynamic, kind of the mixing in science and I want to say maybe engineering or technology, because the rate at which they move, software engineers are so focused on speed of deployment, right? Getting things out into production quickly. While researchers, their road is a little bit all over the place, but that's so important, especially for machine learning and data science. It is largely experimental, and one of the challenges that we deal with, and we're often talking about is how to, minimize the errors that happen from taking these research ideas and getting them into production. And not only for production, but being able to utilize the right tools for the right jobs. Because a lot of the times you end up making your own ad hoc solution, which is what a lot of data scientists end up doing, right? They end up, doing whatever it takes to make something work. But one thing I wanted to highlight, and it's something that it's kind of implicit in some of the things you guys are saying. It sounds like there is a close relationship between best practices and tooling. That somehow the right tooling can enable actually some right practices. And I wanted to ask you guys a little bit more about that. What are your thoughts on just that relationship? Do you think that that's there, or are they two separate things?
Yeah, that's a good point. Maybe I'll agree with you in two different ways. Like, I think as a software engineer, I first want to do something 20 times before I realize I want to build a library around that, right? And so software, to a certain extent, encodes best practices. Second, what I would say is software also allows you to communicate best practices to people who have no idea about those practices, right? So like the data scientists that we're all talking about have no idea the best practices around security, right? That's not something that like they're going to have best practices around. We're gonna do that a bunch, we're gonna write some software, and then we're gonna communicate those practices to other people with software, or more likely with services, with other systems. And that's really, where companies like Coiled come in, is where software like Dask comes in. People don't know how to do a distributed join on GPU data frames, right?
Yeah, it's hard.
There's like 5 different software packages you can sort of throw together to make that happen.
Yeah. Well, one of the things that I was doing some research and reading about Coiled, and I took some things that I thought you guys really cared about, would like to highlight them. So one of them is data literacy. Let's talk about data literacy. Why is that important to you guys at Coiled?
Well, I think it's probably more important further up the funnel, so to speak. I do think that the type of people who are using Dask already are relatively data savvy and data literate, pardon me. But I do think it's incredibly important it almost encodes best practices around reasoning about data and understanding data. And I do think we also need literacy around distributed compute. And what I mean by that is it's on a need to know basis, but when you think about different stakeholders in an organization with respect to data and distributed compute, you have team leads, you have individual contributors, you have ICs, you have certain people at C-level. And I suppose what I mean by distributed compute literacy or data literacy is they know what they need to know to do their jobs with respect to these technologies. And I think everyone needs to be becoming more data literate. And if you're in an organization that does distributed compute, you need to have a certain amount of distributed literacy in order to do your job. And maybe it's minimal, or maybe it's getting more and more. One other, and this is slightly tangential, but it's about building data products.
So good.
Example I think about is, let's say we have a chief people officer or a head of HR who uses a machine learning product to in their hiring flow, right? Let's say at the top of the funnel, right? Do they need to know about k-fold cross-validation? Probably not. But they do need to know about the difference between false positives and false negatives, as opposed to just pure accuracy, right? And confusion matrices, and understand the biases implicit in this type of stuff. Now, in terms of building best practices into products, a product like that could actually inform any user of this along the lines of what's happening in there. So that kind of speaks back to this idea of encoding best practices in software and products as well. Because the danger is in building products that can do like data stuff at scale, we may be equipping people to be dangerous as well. So having best practices and education built into products in that respect, I think is key. That harks back to Matt's point of individual contributors who maybe don't understand, like data scientists who don't understand the ins and outs of security and authentication and data access and that type of stuff. If you can build that into the product, so the IT people maybe have the access to that and understand what they need to do there, but abstract away all the details that the individual data scientist doesn't need to know. I think that's best case scenario.
Yeah, that's awesome. So there's this trade-off here, right, where you want to, broaden access. You want more people to have access to not only compute, but the right tooling to utilize that. But then you also want them to know only what they need to know, right? There's not, like a data scientist has to often wear a lot of hats nowadays. There's been a lot of talks we've had in the past around, being a full stack data scientist. But sometimes, in my opinion, it's actually counterproductive. Like I don't need to know, a lot of these things, and I could be spending that time elsewhere. That opportunity cost of me working on making my job work in a Kubernetes cluster versus just doing what I know how to do. And I think that there's a balance there. How do you guys think about that balance between enabling data scientists to have a lot of power, right? Powerful compute, but also use that wisely? Because I'm sure there's some concerns from like an SRE about resource utilization and underutilization, overutilization, things like that.
Yeah, and a lot of that is just about visibility, right? Can we surface what's going on to the user so they understand if things are fast or slow and why they're fast or slow? Can we surface things to IT so they're aware of, how utilized is their cluster? Should they be putting controls in place? Can we surface things to the person whoever's paying for stuff? How much money did we spend parsing CSV files last month, right? How much would we save if we switched to Parquet, right? And so I think, so coupling that power with visibility, with observability, might be the term that this community responds to, I think is critical. It's also really fun too. Like it's actually, so like Dask famously has this dashboard, which people love. It's very, very visual. And the secret is that that dashboard was designed not for users, it was designed for me as I was building out algorithms in Dask and thinking about heuristics. Like I needed that to make things good. But now as a result, like that visibility goes to everybody. And that really, I think, elevates the level of understanding of everybody that's touching that system. Right, and so that's something that I think a tool can do. A tool can teach you as you use it.
Yeah, and maybe, and I don't know if you were thinking about that as well, but when you're actually utilizing these things in production or whenever you're doing your work, it's important that the monitoring process also has just as much care, right? You're thinking about what's going on, not only usage, but we've talked about this before when you have a model in production, and you're monitoring its prediction values over time to see if drift occurs, or if your features are just going all over the place. And that to me is not just about finding bugs, but about again reducing the bust factor, I guess, sharing knowledge, making sure that more people are included in this process. This is something we're going to talk about as well, where there's various stakeholders in a data science team, right? And there needs to be, and maybe we should even just kind of get to that.
I think that's a good idea. I do want to add though, I think machine learning is such an interesting space to think about tracking best practices, experimentation, because historically, like when I used to do machine learning, I'd be writing down by hand, my scores, and then putting it in a Google sheet or something like that, and seeing the rise. Of course, a lot of companies have built their own internal platforms now to deal with this type of stuff, but we do see the rise of weights and biases and Neptune AI and these types of things to try and solve this for a broader class of people. And I think that type of thing, it's such a burgeoning discipline, is really interesting and key.
Absolutely. Yeah. I mean, this whole community is really revolving around some of that because it involves a lot of key players. So you have the data aspect, which requires its own set of practices, the modeling, which requires its own set of practices, the infrastructure, and then there's the monitoring aspect, the test. There's a lot of moving parts in this, and I do think that's why this is especially important for the community to think about this, because I don't think one person or one company can necessarily have all the answers to that. And it's great to hear how different people are kind of dealing with the same sorts of challenges, maybe sometimes at a different scale, but we're learning how to kind of collate what actually works in these situations and communicate them.
And kudos to all of you for creating a community around it, because historically, a lot of this stuff is siloed in large, powerful organizations, right? So actually having these discussions in an open space is awesome.
Yeah, that's what we're all about. Well, let's get into some of the things around the data science. What makes it so difficult? One, we all know that with more data and more complexity, data science at scale can be very challenging, right? You have lots of data, requires lots of setup, infrastructure, and then even the expertise to maintain and make sure all that process is running. Why is this something that's more prevalent now? I know that you were mentioning, when you were doing some work, kind of doing things ad hoc, it's kind of sloppy, it's messy, you're all over the place. But now it's becoming much more, there's a lot more process, which I think is actually good. But it's also important to balance that freedom to experiment and play. Sorry, go ahead. You want to say something?
Yeah, I was just, and I'll let Matt speak more to this with respect to what we're doing at Coiled and what he thinks about it at Dask. But one of the reasons, I just want to say it slightly provocatively, but one of the reasons I think data science is so difficult is because it isn't real. Data science isn't a single thing. It's an amorphous blob of ad hoc techniques and tools and methodologies and questions that have kind of been thrown into this giant bucket. So it isn't I mean, someone doing distributed machine learning, deployed doing like real-time servicing recommendations or whatever it is very different to someone doing analytics and building dashboards and that type of stuff, right?
Yeah.
So the other thing I think that's relevant here is that it's evolving so quickly. The tooling is evolving so quickly. The value it's delivering is evolving so quickly, and the methodologies are. So keeping up with that is one of the biggest challenges. And that's why we're really interested in building tools that are nimble and agile enough and ergonomic enough to allow data scientists to use it from their own environment and use the entire open source ecosystem that they're comfortable using.
Yeah, so maybe I'll jump in on that. So I think data science or machine learning generally, exploratory machine learning, let's call it, is distinct from other kinds of computing because it is exploratory, right? People are they're doing something that has not been done before, right? They're looking at data they've never seen before, and they're using techniques, statistical techniques, computing techniques, interpersonal social techniques in order to explore something new. It's all about novelty there. In order to do that, they pull out all the stops. Right, they're not just going to use one tool. They're going to use, they're going to use Jupyter for a bit. They might use an Excel spreadsheet for a while. They might make some phone calls, right? They might use a GPU. They might use a CPU. They might use an FPGA. They're going to use whatever they can grab at hand to solve their problem. And that, I think, is really what typifies, what exemplifies sort of data science exploratory workflows. The challenge, I think, that we see in the MLOps community or in like the scalable computing community is that when you're used to using every tool at your disposal, from switching to Excel, to Jupyter, to a GPU, to an FPGA, to a phone, replicating that same experience on a cluster in the cloud or on some Cloudera machine you got somewhere else is extremely hard, right? You're in for like a world of pain or a world of lowered expectations when you realize, oh, it's not my laptop, right? I don't just have one hard drive that has all my software. There's now hundreds of containers. What's this Docker thing? Or, I can't just like spin up a Qt application to go explore this stuff. I've got to do everything through the web. Wait a minute, how do web proxies work? And so it's really that experience of trying to recreate the sort of the laptop experience, which I think is just painful in general.
Oh man, yeah. Just thinking about the way I solve problems and how messy it is and convoluted, and oh gosh, yeah, that you're right. That is part of the challenge. It's just like, allowing their, a data scientist freedom to solve problems in whatever way they see fit. And you're right. Sometimes it could be something super simple. And I learned that actually when I first was, because prior to being a machine learning engineer, I was working as a data scientist. And I was, one of my takeaways from that experience is that being a data scientist is being a problem solver. That's essentially what you do. You're a bit of a generalist and you kind of wear a lot of those hats. And I like that. I like the complexity of that. But I can also see from an operations maybe point of view or IT point of view, how challenging that could be, because you want to extract as much value from that, right, for the business. But it's like you want to do that, but you also want to let it be free and enable some of those things.
Yeah, and so I mean, Dask was really designed to pretend that your cluster of machines was like your laptop to a certain extent. We tried as much as possible to make all of those sort of physical machines you have look kind of like your local Python process. And we tried very hard to hit Python APIs, make everything look really familiar and sensible. What we found, though, is that there's this other set of problems, this sort of IT set of problems, and that's where kind of Coiled is trying to solve. But it's all about that sort of bringing the exploratory local experience to larger and larger scale and trying to hide or pretend that these other challenges don't exist, when in fact they very much do.
That's right, finding the right set of abstractions. Well, one thing I'm super interested in is open source. And I know that you guys are very passionate about open source. I know we at the community are as well. And one question I have, and because you guys are kind of working in this space, is how can a for-profit company complement OSS, open source software?
There's like 20 answers to that question, but maybe I'll jump in first. So I think if you look generally, if you look historically at maybe previous technology stacks, maybe like SAS and Oracle, large companies bought a large technology stack and a bunch of support around that stack, and they were happy for a while. And then eventually, the open source came in and it just blew away those technology stacks. Hadoop came in, Python came in. Company says, this is great. This software is way better. We don't have to pay for it. Awesome. But when they threw out those large companies, SaaS, Oracle, whatever, they also threw out a lot of other things that were attached to the software. They threw out, like a support contract. They threw out a system to distribute that software. They threw out, paying the developers who are actually fixing bugs, or a relationship with those developers who are fixing bugs. And I think what we're seeing is all of these sort of open source companies are fitting different parts of what was sort of left behind from these large sort of software monoliths. They're providing support is a very easy play. They're providing funded development. They're providing managed services or hosted versions of software, like what Coiled does with Dask. And that, I think, is a very clear benefit for everybody. Additionally, I think we have these sort of two communities, these sort of business communities, and we have these sort of open source development communities, and they actually don't know how to talk to each other. Right? There's no way that like Ford or GM is going to open up a contract with the Pandas developers. Right? They're not a legal entity that you can really engage with. So you need this sort of interstitial group that can talk to both groups. I think commercial open source companies can serve that intermediary role, which is as much a business role as it is a social one.
I'll build on what Matt has said by first stating that the question you asked is one of the most important questions of now, hands down. And to kind of signal that, I'll quote, Matt's heard me quote Brian before, but Brian Granger said at the second JupyterCon, it was a great talk, I think it's online, that and as a physicist, he of course framed it as a phase transition. He said, we're going through a phase transition in which no longer, previously, institutions had individuals using open source. But the phase transition is going to a point where organizations and enterprise are adopting open source at scale, right? And you look at, I mean, big examples involve Walmart and Capital One and JPMC, several of which actually use Dask for what that's worth. But I think what that speaks to is the fact that we do need to figure out how enterprises can adopt OSS as successfully as possible. Matt signaled a variety of challenges there that for-profit companies can help to solve. I also, and I haven't developed this a lot, so I'd be interested in your thoughts on this, but I do get the sense, besides a few edge cases, OSS tools are really good for ICs, but they don't necessarily
ICs?
solve all the, individual contributors. Yeah, sorry. So they don't necessarily solve all the large-scale institutional challenges. So if you think of an organization like a network, right? OSS is really good at solving for the nodes, but not necessarily for all the edges, right? And so if you want to solve for edges between IT and data scientists, management and data scientists, IT and management, you do need, in this framework at least, one way to solve that is for-profit companies providing support training, but also building products to solve for these types of challenges.
I'm picturing the graph. I see it in my head right now.
And one thing that
the edges, man, focus on the edges.
One thing that I was just going to mention on this is, if we look at the last 10 years, some of the biggest companies have been these open source companies, besides what just happened recently with Snowflake, right? Like you have some gigantic companies, and I was just reading about an article on Medium, I'll try and link to it in the show notes, about basically like how open source is eating the world. It's taking over in a way. And really, I think that shows the viability of it. It shows that it is something that is people preferred in a way. And so to make money off of it, I find really interesting with the companies, how they're deciding to create a business plan around it. And then since it is open source, anyone can come and create some kind of business plan around it. And I know I saw a funny quote somewhere on Twitter where it was like, yeah, Amazon getting into your like, what was it? Amazon getting into your business. No, man, I'll have to find the quote. It was like, Amazon is stepping into your field of business or becoming a competitor. And then there is the part where it's like Amazon becoming a competitor with your own open source technology, right? Like,
yeah. And that maybe brings up a really interesting point. So you're talking about, open source software is eating the business world. but also the business world is eating open source software at the same time, right? And like, maybe, NumPy and TensorFlow are different in some ways, right? NumPy is maintained by a community of volunteers who've done that for the last decade, many decades actually. And they're, academics, they've got academic honesty, there's like a bunch of transparency there. And there's TensorFlow, which is maintained by Google, there's Google project managers, super successful project, has done a lot of great good for humanity. How do we as a community now respond to that, right? Is open source software in the future just going to be Google and Amazon fighting over who gets to acquire whatever small startup that was just looking to get acquired with open source technology? Or is this community-based thing where everyone knows and trusts the software, right? There's now so much money around this community asset that now we need to be sort of aware of, open source maintainers need to be aware of the business challenges and the business motivations behind some of these decisions. And if we want to sort of make the rules going forward, we have a relatively narrow window in order to make those rules. And that's something that we need to think about a little bit if we care about the sort of community nature of open source. Maybe we don't, right? Maybe there's different levels of open source. We may care about some versus others.
Well, I think we do. And I think it comes down to some form of segmentation, right? Because you're absolutely right. TensorFlow is quote unquote open source. Is its governance model one that we think of and resonates with us as people in the open source community? Maybe not so much. So I think it's important to have these distinctions and be intentional about them.
Yeah, and one thing that somebody just brought up in actually our Slack was how in a real open source project, a really well-run one, is where not only one person makes money from that project, right? Where it can create an ecosystem of different companies that are thriving from that. So that's another thing. If it has the scope and it's big enough, and I instantly think of something like Kubeflow. This is where we were talking about it. Kubeflow is not only the maintainers that are arguably not making any money, but then you get all these other people into the ecosystem, and there's lots of companies that can be supportive of the technology, and they are then there's companies created out of this. So
this is really challenging, as I'm thinking about some of the points you guys are making, like I can't quite wrap my head around it. And I would be, if I was a business and I had to think about some of these things, it'd be hard. There's a lot of trade-off to consider. But one question I have around this is like how, and this is maybe just more my curiosity, how do you encourage more people to contribute to something and to ensure quality? Because I know that can be difficult when you're working with a lot of different people. How does that, maybe Matthew, you can speak a little bit more to that with Dask. How does that work? How do you make sure that things stay high quality, that are working really well? But yeah, maybe you have some thoughts on that.
One might also ask the question, like, how do you run a business successfully? Right. There's actually like a ton of answers to that question. There's a bunch of different philosophies around that question. I'm not sure there's like a single answer. Right. I think we ran Dask very much as like an interpersonal thing. So like we try to get companies engaged. We try to get their maintainers trained up. We try to find incentives for them to keep being around. It's a community. How do you build communities? There's a, ask, I think,
it's hard.
Has some thoughts on this too. There's not a clear answer to this. That's a longer conversation, I think.
Yeah, fair enough.
I do think that there are a few things I've seen Dask do and scikit-learn do among other packages really successfully. In terms of at least developing the new contributor space and awareness among new users that it is possible to contribute and not just be a user. And that comes down to documentation. It comes down to like in-person community building sprints. I mean, it's not scalable, but that's how these things start. And then simple things like on an issue tracker, having tag for, this is a good issue for a first-time contributor to do, or, work on the documentation to become more familiar with how we deal with pull requests and that type of stuff. And I think opening the space of contributions to a far wider audience is really helpful there.
So I wanted to ask real fast a question from Dan. Gerlach, who is a mutual friend of all of us, we all know him.
Mhm.
He was wondering, like, do you see Collide operating within the Dask ecosystem? For example, will you be developing proprietary extensions or open sourcing all of the core tech?
Yeah, so this is a question that we think about when making open source companies. How do you monetize something? I think how most companies start, like ours, we sell infrastructure that surrounds Dask, right? So if you go to coiled.io, you can sign up for cloud.coiled.io, Coiled Cloud, and you can get up running, on a hosted system really easily. There's a bunch of features we could talk about there, which are not Dask, but they're peripheral to Dask. It's all the infrastructure that you need in order to get up and running quickly. So that's not competitive with Dask, right? That's something that's sort of on the side. And that's the thing, sort of the open, that's like a nice model for open source companies. What happens sometimes, and we'll see if this happens with Coiled, is competitors show up, they offer the same thing. When Amazon shows up and offers hosted Dask, how do we respond, right? And so the lever that we have that Amazon doesn't have is control over Dask itself. And so you want to see, how can you sort of use your asset to be competitive without strangling the community and without holding things back. And that's like a very nuanced thing to try to do. And we've seen companies like MongoDB do this. We've seen Confluent do this. And that's an open question. And we're going to see what happens. But we are starting how I think most companies start, very maybe perhaps naively, but naively altruistic. We're not trying to sell Dask. We're trying to sell support around Dask to make it much more successful. We believe that as Dask is easier to use, we will make money in the future.
And on top of that, I think that has the added benefit of feeding back into the Dask community. I mean, the more tools and more products and services around that make Dask easier to use, the more people, hopefully, that will be using Dask as well. So we're also growing the entire Dask community and family, which is really exciting.
This is a great time to start talking about Dask itself. I know we've had previous episodes, so forgive us if you guys have heard this already. You guys know Dask, but I do know some people aren't. We're going to dive a little bit deeper into what Dask is and what we're trying to do, what Coiled is doing with that. So let's start with what is Dask. Matthew, can you just kind of break it down for someone that never heard of it?
Sure, yeah. So Dask's original goal was to parallelize other popular Python libraries like NumPy, Pandas, and scikit-learn. And so Dask provides very much libraries, but which scales out to a single machine for large memory data sets or onto a cluster of machines. So if you want to run your Pandas code on 20 terabytes in the cloud, Dask can let you do that. Internally, what we found, so in order to build that system, we had to build a relatively sophisticated dynamic task scheduler. And I'm not sure how much in depth we want to go there. But there's an engine inside of Dask, which runs parallel code. And it turns out that lots of users said, hey, the system that you built to parallelize Pandas and NumPy looks great. I actually don't care. I just want that internal engine, please. Because they're building their own very different thing. And so now about a fair majority of Dask use is actually just using that core system. And so that core engine of parallelism ends up powering lots of other libraries. XGBoost, Prefect, BlazingDB, there's lots of other systems that are now built on top of Dask, as well as lots of, if you go to any hedge fund in New York City, they'll be like running some weird trading strategy on top of Dask. So Dask is also sort of a low-level general purpose library for parallel computing. It's all in Python. It's sort of all the parallelism you need to build out cool stuff without any of the opinions that maybe like a Hadoop or MapReduce framework or Spark framework would come with. So it's a little bit lower level.
Awesome. That's a great answer. And can we break down some of those concepts in that for maybe some data scientists that are less familiar with distributed computing? Well, what is parallelism and concurrency? First off, what is parallelism? How would you define it for someone that maybe has heard this term, as it's kind of been hearing it thrown around, but what should they know about parallelism?
I recommend people take a look. If you go to YouTube and you look for Amish barn raising, it's actually a great example of parallelism. So there's time-lapse videos. Yeah, so people who are not maybe in the United States, the Amish are a community in the United States who are very pastoral. They sort of live like you'd expect people living in maybe the 1800s, 1700s. and they raise barns. And you get a whole community of people together, and they build a barn in a day. And if you look at these videos, you will see hundreds of people working together towards one outcome. They're building a barn together. And it's actually really interesting to think about, if you had 100 people building something, how would you instruct them on how to construct that barn as efficiently as possible? Now, if you're one guy, great, you're going to go build this post, you're going to build this post, you're going to build this post, put some paneling on it. You're going to build a roof, you're going to put things on it. Now you have 100 people, it's like a scheduling problem. You got like a foreman. How are you going to direct everybody to do all these different things? That's parallelism, right? You've got all of these resources. You've got this thing you want to do. How are you going to plan things together? That's not quite like a technical definition, I understand.
That's
but it's
a great,
definition.
I really like that one, actually. Yeah, you have to maybe we'll share the link for that video. You mentioned a video, or is there something that you have in mind with that?
And look for Amish. If you just go to YouTube and do a search for Amish barn raising time lapse,
nice.
You will not be disappointed.
Awesome, I gotta check
but
that
there's
out.
also fun. There's fun things there. Yeah, there's fun things there too. Like, what if a worker gets hurt, right? How do you replace them? Oh, that's resilience, right? How do you do you all take a break for lunch? Like, oh, that's downtime, right? There's lots of different things you can think about with that analogy. It's quite fun.
Love that. I love that. Why is it so hard though? I think some people, I know that when I was first learning about some of this stuff, I just, the idea of just, taking some big work and spreading it into little pieces of work. Okay, that makes sense. But then why is it so hard to put things back together? Why is it so hard to schedule these things? And in particular with Python, why does Python need a whole new tool to enable that? Or maybe some other tools as well?
Yeah, you can split the difficulty into two parts maybe. One is like constructing that plan, right? Great, I've got 100 carpenters, I've got 2 masons, I've got these 3 people who are sending food around. How do I use those people effectively to build this barn? And you can imagine building a schedule. We go talk to your nearest foreman, and they'll talk to you a lot about scheduling and a lot about making plans to build stuff. And that's an interesting challenge, right? Planning everything out, logistics, administration. That's a challenge. There's a second challenge of how do you actually interact with the hardware that you need to interact with? How do you interact with your network? How do you interact with compression libraries? How do you interact with Kubernetes? How do you interact with all those sort of nuts and bolts of how our computers are hooked together today? And that's much more incidental, right? And that's maybe like the less fun, but maybe more pragmatic part of parallel computing. You could have done all of this before, right? So the previous systems to Dask, so there was Spark, but Spark wasn't maybe quite as flexible as you would want. It kind of built one thing. If you want to build a barn, maybe if you want to build like a house, Spark was great. If you want to build a barn or a car or like a shed or like a rocket ship or a Roomba, Spark maybe wasn't quite right. The other option was to go way lower level to something maybe like MPI or 0MQ, or to manage sockets yourself, maybe with like threads and queues. If you're sort of like been a computer scientist, you can kind of think about different kinds of ways of plugging all these pieces together. Dask is maybe like the Tinker toys that like have all the common patterns you're going to want, but don't force you to think about, what bytes should I send across this wire in order to signal to this other computer that this other computer has gone down, and how do I make sure that like if that wire goes down during that time, we're going to resend a message, right? So Dask is handling, it's increasing level of abstraction a little bit to make it, I think, easy for most sort of people who are proficient in Python. But it's not raising the abstraction so high that you're up at like the SQL database level where you can no longer really build the barn you wanted to build in the way you wanted to build it.
I don't know
if
anyone else caught that, but Matt said, if you want to build a rocket ship or you want to build a Roomba. And I
actually usually use the term mechatronic cat when I talk about this stuff. But yeah, Python people do weird stuff, it turns out. Right? Python people do lots of weird things. And yeah, their creativity knows no bounds.
Love that. So a couple of things I'm going to kind of move a little bit ahead, but you mentioned before that Dask has the ability to work really well. Sorry, I'm just going to, excuse me one second. Yeah, so it allows you to work nicely with other APIs. So it integrates well with other tools that a lot of data scientists are familiar with. But it also allows you to do some more complicated things like dynamic task scheduling. Can we talk a little bit more about that and why that's useful for data scientists? Oh, 1 second. There you go. I think you have to unmute. Oops.
You're muted, Matt.
Uh-oh.
Yeah, no, we're good. Sorry about that.
Cool.
Weird
No
Zoom
worries.
fail. My apologies, everyone.
No, the suspense was great. People really want to know about dynamic task scheduling now. Tell us.
Yeah, so again, so Dask does these high-level APIs now by pandas scikit-learn. Beneath that, there's this engine. That engine is a dynamic distributed task scheduler. What that means is that you can tell Dask, hey, I've got this Python function, it's my own function, go run that somewhere for me, please. Right, and actually I've got 100 of those, so go run those wherever you happen to have space. And so Dask will run those Python functions. It could be any function. It could be a TensorFlow train function. It could be something you wrote. And we're just going to run it on the hardware that you give us. Then you might add something more complex. You might add data dependencies. Right? You may say, okay, well, after you finish loading up the CSV file, when you parse it and then when you train it, then once all of those things are done training, why don't you try combining them with some sort of bagging estimator or whatever. And so you might have a more complicated graph that you want to compute that has dependencies between those different tasks. Okay. And so now you start thinking about well, where's that data living? How do I move it across a wire? How do I make sure that I reduce data movement? Right? I want to keep track of where all those big pieces of data are, so I move the small pieces of data to them. What happens if a worker goes down? So you get sort of some interesting complexities there. Then you might add another layer onto it. Well, wait a minute. What if I've got a new file coming in every second? How do I then update my graph on the fly in real time and keep pushing out some other results also in real time? Now you're going a real-time distributed task scheduling. And so that's what Dask provides.
So it sounds like the problems that it's trying to solve, we've kind of been getting at some of them, is one, not only increasing speed by parallelizing things, right, but also increase reliability because of the fault tolerance, right? So if one worker goes down, another one could carry that load. And why is this in particular important for data science? I mean, it seems like there's how often will a data scientist run into the need to, use these sort of tools to have, things run faster, to have that reliability? Do jobs fail that much? Is that something that you guys see as a big problem?
Yeah, it's not often a problem unless you're operating on the cloud with cheap instances. If you're using on-demand pricing or spot pricing or preemptible nodes, often those nodes can go away. And so that's something you care about, right? If you can support resilience, then you get to use cheap machines. You get to sort of fit in within the rest of the cluster, all the little holes.
So real quick before we finish up, it sounds like you mentioned Spark before, but it sounds like Dask is a little bit not only more Pythonic, but more lightweight. Why is that a plus, do you think, from your side?
Yeah, there's a bunch of reasons. One, it's easy to pip install if you want to, right? It's included by default in Anaconda. It's everywhere. It's easy to get up and running. We talk a little bit about clusters, but actually most Dask users just use their laptops, right? They've just got, by default, Dask will just spin up a thread pool. If you import Dask, it spins up a thread pool, runs things on there. It's very accessible, I think, to individuals. It's a really much easier place to start. It can grow up to running on the world's largest supercomputers, but you often just start with a little small engagement. I think what's maybe more important, where we sort of had more pressure to be lightweight, was among different library authors. And so Dask gets often integrated into other packages that they are usually very, very picky about how lightweight Dask can be.
What's an example, really big just so we have an idea?
Scikit-image, scikit-learn, Facebook's Profit Library, XGBoost, Prefect. There's lots of things. If you go to dask.org, at the bottom, there's dozens of libraries that all integrate with Dask. And so this is maybe actually a really big difference between Spark and Dask. In Spark, they're reinventing a whole data science stack, right? They've got Spark data frames instead of pandas. They've got MLlib instead of scikit-learn. They've got they've got GraphX. They've got all these different libraries that they're building on top of Spark, the engine. Dask isn't an ecosystem. Dask is like a little bit of parallelism that we're injecting into an existing ecosystem. So, you know, Dask is just part of the broader Python community of libraries. We're not trying to reinvent everything. We're very lightweight in order so we can do that. And as a result of being lightweight, we get all of that leverage of all those other people building awesome libraries. And as a result, Dask is actually much more like a community solution, right? You don't use just Dask, you use Dask plus 50 other libraries, which are maintained by thousands of people around the world. And yeah, we're not in one company, we're in thousands of companies, right? And that's like really a cultural difference between Dask and most other open source sort of scalable computing things. We grew out of the community rather than trying to build a community around it.
And I'll build on that by saying it's important to think about the barrier to entry for tools like Dask and Spark. And I'm not talking about, you know, really technically savvy engineering DevOpsy type data scientists. I'm talking about the adoption of Python has been immense over the past at least five years, particularly in the data science space. So there's a whole new breed of analysts learning Python who until recently were building their models in Excel, right? And if they need to do some sort of distributed compute, we're talking potentially hundreds of thousands, if not millions of people, right? In the coming decade. And if they're going to do distributed compute, they've learned Python after going from Excel to Python. Do we then want to ask them to go to something like Spark where they get thrown JVM errors when they do imports? Or do we want to meet them where they are? And of course, Spark has its own pros as well. Don't get me wrong. But do we want to meet them where they are and have APIs as close to the tools they're already using, which the Dask data frame, for example, mimics, and the Dask array mimics with respect to Pandas and NumPy respectively. And also the fact that it, you know, for the most part runs Python code and the Pandas and respective NumPy code in the back end means the actual execution mirrors the mental model of what they have, of how the codes actually work. So I think it does open the entire space to a whole new breed of users, which I'm really excited about.
Guys, this has been a really awesome conversation. I just want to close with a question. Where do you guys see as the future of Dask? Where do you think things are going to be heading? I don't want to take away from the point, Hugo, about, you know, making things easier. That is so true. But do you see more of that? What's in store, and what can we be prepared for?
Oh, you're muted, Matt.
Sorry, Matt. It's probably my fault.
Suspense again. The suspense again, man. What is it going to be?
I'm not intentionally muting myself. I suspect one of you are playing a prank on me.
No. I'm muting it because of the echo. I'm just trying to like alleviate the echo when someone else is
talking.
talking.
I've got echo going on. My apologies.
No worries about it. Yeah, no worries. Good.
I can resolve that. Yeah, I think Dask is expanding in two directions. I think so horizontally, we see lots of other domains starting to pick up Dask, right? So, you know, Dask has been really common in financial services, in government, in, you know, geosciences. We're seeing a lot of growth in life sciences. We're seeing a lot of growth in a lot of time series analytics. We're seeing a lot of growth in other fields. And so you'll see a lot of other libraries starting to add Dask support in other domains that we haven't culturally been in before. And that's super exciting. I think also what we're seeing a growth of smaller and smaller groups who want to use distributed computing. And so I think that we're going to start seeing a lot more accessibility in distributed computing. And that's really what we're focused on in Coiled. It's making so that anyone from the largest companies to the smallest companies have access to scale without knowing all of those challenges that we've talked about during this session, right? And that's, I think, where that accessibility barrier is going to lower a lot. And I'm really excited about that.
Same here. How about you, Hugo? Some final thoughts. What do you think?
So I agree with everything Matt has said. I look forward to the day, which could be 5-10 years away, where Dask is taught at junior high. I think we are.
That'd be great.
Yeah, we are entering a space where the Py data stack is going to be taught at junior highs, like ideally sooner rather than later. And if people want to think about distributed compute, a foundational way to do that in the Py data ecosystem is Dask. So I'm really excited for that. And we're doing what we can at Coiled to help with that mission as well. I would love anyone in the community to let us know what they've used Dask for. We run live streams, Science Thursdays. So if you have a cool Dask story, please ping us to come on that. But I definitely would have to fire myself if I didn't let you know that we've just launched our cloud product and made an announcement with respect to funding. So please do check out cloud.coiled.io, and we'll include some links in the show notes as well. But we'd love your feedback there as well, everyone.
Sweet. Demetrius, why don't you close us out with your sweet, soft voice?
I just want to say that that barn raising story, it stressed me the fuck out, man. Thinking about that, I'm just thinking about how I can barely coordinate with my wife to make dinner in the kitchen. How can 100 people coordinate raising a barn together? That is nuts. So that's a little off topic, but this has been a very stimulating conversation. I appreciate this so much, fellas. This was like, you blew my mind on so many levels, from the barn raising to just the open source chat. And then, teaching teenagers a little bit of Python. Why not? I like it all. So hopefully, we will be seeing each other again next week, and we'll be talking more with you all. This has been an incredible talk. Really, thank you again.
Thank you so much.
My pleasure.
All right, guys, have a great evening. Thank you for listening, everyone, for listening in another coffee session. It's great to have you guys. Bye.